Hey everyone, welcome back. Ready to dive into something kind of surprising? We're going to be talking about LDL cholesterol today. You know, the bad kind.
Yeah.
We hear so much about how what we eat affects it, but what about all that other science-y stuff behind it,
Right.
like genetics and even evolution?
Yeah, it's interesting how it all connects. Cholesterol is really a great example of how interconnected our bodies are.
Exactly, so let's break it all down. When we think about cholesterol, we might think about, I don't know, like a big plate of fries or something.
Right.
But our livers actually produce most of our cholesterol.
Yeah, like the majority of it. It's not just about the food.
That's crazy. Like, how much are we talking?
It's a lot, like around 90%. Our bodies really have their own cholesterol factories going on inside.
Whoa, 90%. That's wild. So it's like, even if we try to cut back, our bodies are still making a ton of it.
Exactly. And the key player here is an enzyme called HMG-CoA reductase.
HMG, what now?
HMG-CoA reductase. It's kind of mouthful. But it's the enzyme that those statin drugs actually work on to lower cholesterol.
Oh, statins, right. So we'll circle back to that.
Yeah, for sure.
But, okay, so the liver's pumping out all this cholesterol, but it doesn't just, like, unleash it all at once.
Definitely not. It has a system like a cleanup crew. They're called LDL receptors, or LDLRs for short.
LDLRs, got it.
They go around, and their job is to remove LDL cholesterol from the blood.
Okay, so the more efficient these, what were they called?
LDL receptors or LDLRs.
Right, those. So the more efficient the LDLRs, the better our body is at keeping that bad cholesterol in check.
Exactly. And that's where things get really interesting. See, the number of these LDL receptors that we have, well, that's determined mostly by our genes.
Oh, wow. So our DNA plays a role in how well our bodies handle cholesterol.
Big time.
Yeah.
And a good example of this is a condition called familial hypercholesterolemia.
What now?
Yeah, it's a mouthful, familial hypercholesterolemia. We call it FH for short. Basically, people with FH, they have way fewer of those LDL receptors.
Oh, no. So their bodies have a harder time clearing out the bad cholesterol, even if they're being careful about their diet and stuff.
Exactly.
And how common is this FH thing?
You know, it's more common than you might think. Something like 1 in 250 people in the UK have it.
Wow. I had no idea. That means someone could be walking around with this and not even realize it.
Exactly. It's often passed down in families without people even knowing. And that's what makes it kind of scary, because it can lead to serious heart problems early on.
Really? Like, how early?
We're talking heart attacks in people's 20s and 30s.
Oh, wow. That's really young. It's like no matter how healthy you try to be, your genes can really have other plans.
It's true. And to make things even more complicated, it's not just the number of LDL receptors. There's this other protein, PCSK9.
PCSK9, what's that do?
Well, it actually regulates the LDL receptors.
Regulates how?
It can actually break them down.
Oh, no. So less cleanup crew. That's not good.
Yeah, not ideal. And unfortunately, variations in the PCSK9 gene can make it even more active.
Meaning it breaks down more of those LDL receptors?
Yep. And guess what that can lead to?
Higher LDL, even if you're eating nothing but salad all day long. But you know what's really wild? I heard that having higher cholesterol might have actually been helpful to our ancestors, which sounds crazy, but...
I know, right? It does sound kind of counterintuitive.
Yeah. So how does that work?
Well, there's this theory that low LDL receptor activity, which we know leads to higher LDL, might have actually protected early humans from certain bacterial infections.
Oh, interesting. So back then, when infections were a much bigger threat and people didn't live as long anyway, that genetic quirk could have been a survival advantage.
Exactly. Like, imagine inheriting a really heavy winter coat. It's great for an ice age, but not so much for a heat wave, right?
That's a great way to put it.
Things that helped us survive back then might not be so helpful now.
It's like an evolutionary hangover.
Yeah, exactly. Yeah, that's a good way to describe it.
Okay, so we've established that genetics plays a huge role here. Maybe even more than diet for some people. But we've got to talk about the elephant in the room. There's this big emphasis on low-fat diets for high cholesterol. Does that actually line up with the science?
It's complicated. I mean, diet definitely plays a role, but it's not the whole picture. And for some people, especially those with genetic predispositions, diet alone just isn't enough to get those cholesterol numbers where they need to be.
So it's like trying to outrun a cheetah. You might be fast, but the cheetah's built for speed.
Right, exactly. So when diet alone isn't enough, that's where medication often comes in.
Right, like statins.
Exactly. Statins are one option. They work by targeting that HMG-CoA reductase enzyme in the liver.
The one we talked about earlier.
Yeah, so it's like turning down the dial on the body's own cholesterol production.
Makes sense. But what about people who can't take statins for whatever reason? What are their options?
Well, there are other medications, like bile acid sequestrants, and they work bile acid.
Bile acid what now? That's a mouthful. How do those work?
Basically, our livers use cholesterol to make these things called bile acids, which help us digest food.
Okay, makes sense.
What these bile acid sequestrants do is they, bind to the bile acids in your gut.
So they can't be absorbed.
Exactly. And that forces the liver to use up even more cholesterol to make more.
Oh, I see. Clever. So what about those PCSK9 inhibitors we talked about? Those seemed pretty cutting edge.
Oh, yeah, they're amazing. They work by, get this, they actually make the LDL receptors even more efficient.
So it's like they boost the cleanup crew even more.
Yes.
That's got to be huge for folks with FH, right? The ones who don't have many LDL receptors to begin with.
Absolutely. For them, it can be life-changing. It gives them a way to get those cholesterol levels down, along with the statins.
Amazing how far we've come, huh? But it makes you realize how important those cholesterol screenings are.
Oh, for sure. And they're not just about getting a number. It's about having that conversation with your doctor. Looking at your own individual risk and everything.
Right, like a heart health game plan just for you. So if someone does find out they have high cholesterol, it's not a time to freak out.
Definitely not. It's an opportunity to work with your doctor. You've got options.
Exactly. So we've talked a lot about the liver and genetics. What about carbs? I know we touched on that a little.
Oh, yeah, carbs.
Mm-hmm.
Right. So the type of carbs we eat can actually play a role, too.
Really? So it's not as simple as just carbs good or carbs bad?
It's way more nuanced than that, unfortunately.
Yeah.
There's a lot to unpack there.
Oh, man. Sounds like we need a whole other episode for that.
We could probably do a whole deep dive just on carbs and cholesterol.
Well, there you have it, folks. Always more to learn. We've covered so much today, from how our livers work to our ancestors' genes. But there's one more thing I want to touch on. When we were talking about, identifying people at high risk from birth.
Yeah.
That whole idea of starting treatment early, even in childhood, to prevent stuff later on, it really makes you think.
It's a big question, isn't it? How we approach healthcare in general.
Totally.
Trying to prevent things versus just treating them after they happen.
Exactly. Because, if we know someone's at high risk, we could maybe prevent a lot of problems. Mm-hmm. But then are we, going overboard? Medicating someone for their whole life based on something that might not even happen?
Yeah, it's a tough one. Even if a medication is generally safe, there could still be downsides to taking it long term.
Right, of course.
And what about just the mental side of it? Knowing you have this risk, this thing hanging over you.
That's a good point.
Even if it never actually becomes a problem,
yeah,
just the stress of it, it's complicated.
It really is. It feels like we're in this whole new world of personalized medicine.
We are.
And the more we learn about genetics, the more we're going to have these kinds of tough decisions to make.
Exactly. That's why it's so important to keep researching.
For sure.
And to keep having these conversations.
Absolutely. So we're not just blindly making decisions.
Right. We have to weigh the benefits and the risks,
Mm-hmm. Definitely. It's like that saying, knowledge is power, but
it comes with responsibility.
There you go. And that's on all of us too, not just the doctors and scientists.
Exactly. We all have a responsibility to educate ourselves, ask questions,
right,
be involved in our own health.
Take charge, yeah. Well, we've covered a ton today.
We have.
Learned how cholesterol works, how much our genes play a role.
And all the different ways to treat it.
Oh, and don't forget the whole ancestor thing.
That's right. Who knew our ancestors' survival tactics could be linked to cholesterol today?
It's wild. But that's what I love about these deep dives. We get to peel back the layers.
Right. It's not just the surface level stuff.
Exactly. And hopefully get people thinking, maybe I should look into that more on my own.
Absolutely. The more you know, the better.
Couldn't agree more. Well, that's about all the time we have for today.
It flew by.
I know, right? But thanks to everyone for joining us on this deep dive into LDL cholesterol. Remember, knowledge is power. Use it wisely. And until next time, keep those brains engaged.